Now, today's very first topic is going to be about application deployment. And in this application deployment, we're gonna check how applications and every other software that you're gonna work with is going to deploy. So the concept of cloud is pretty much famous nowadays, right? Because we see in data center infrastructure that how applications and the data that is stored that is concerned with that particular application is accessible from any part of the world, from any device of the world that has the internet connectivity. It's almost our home appliances as well are now getting connected with the internet, and that particular revolution is bringing a lot of new data into the business, and because of which having something that can actually work as cloud infrastructure is pretty much important for internet today. So
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
it has become now a central, you can say, point of touch to how we interact with our friends, buy things, watch TV and movies, and run our businesses and all. Everything is depending on cloud now. And so, is it really? We can say that this can be a subjective question that has to take into account on your personal perspective. But if you ask like multiple people that what cloud is, then you would probably get around well, like same like number of different answers there because everyone has their own perspective towards looking at cloud. Some things that the cloud is basically just a location where your data is actually being hosted. The other person might think that cloud is actually the back end of the business that he or she is running. Sorry, and various other answers can be received from that. Now, you can say nearly half of all the business meetings around the world is being held or is being held by using applications like Microsoft Teams, applications like Zoom, right? And the data is, or the application is actually surviving with the help of cloud itself. So the biggest issue with this particular line of thinking is trying to call like the cloud as a thing in the first place because the key value of the cloud that it gives you a new way of operating the entire IT infrastructure, allowing it to be fast and agile and scalable and whatnot. So today, if you think about the same, companies like Amazon, right, companies like Google, companies like Microsoft, these are pioneers of cloud service providing, right? And even you can say Cisco is also coming up with their cloud services now. So all of these companies do provide cloud services, and they are reaching heights now. You see AWS as Amazon's cloud service providing platform. You see GCP, Google cloud, you can say platform, and Microsoft has its Azure. Cisco also has, I think, Cisco Cloud Profession or something like that, Cisco Cloud Platform or something like that. And they also have ECMS, Elastic Cloud. I think, I'm not sure about the full form, but yeah, Cisco is coming up with that platform, which is going to act as the cloud platform for Cisco. So many startups as well are building their applications and services completely into the cloud as well. For example, Uber is the biggest example that we have. Uber is a complete cloud-based platform. It has completely transformed the transportation industry through a cloud-based application that allows you to easily find someone who is willing to pick you up and drop you somewhere, right? And just like that, you can have in India there is Paytm. Paytm is another organization which has revolutionized how digital payments can actually be expected. Or you have Apple Pay, you have things like Square in the West, right? So things like that are like companies or gigantic companies like these are taking full benefits of how cloud services can actually be used. Uber doesn't own a single taxi of it. Or you can say you have Oyo rooms in India, or you can say Airbnb. All these also do not really have much of a properties of their own. They just rent the property and then provide it to be, you can say, leased out by the customers. So such kind of scenarios are, and all of these platforms are just working based on the application, right? App is their whole sole entity that they own, and the consumers consume the services provided in that particular application. So now there is, I would say, organizations which are set up, because whenever you come up with your business solutions, whenever you come up with your business model, and if you think that you are gonna be one of the cloud service provider, or you are one of the company that relies onto the cloud services for its business to function, then you cannot actually be the one to decide whether that particular application, or whether that particular, I would say, business model is cloud business or not, because there is a complete organization for that. So the organization stands for NIST. Okay, NIST is National Institute of Standards and Technology, which is kind of a US government agency responsible for standardizing weights and measures and technology standards and practices. So NIST is the organization who actually decides what is cloud, okay, or what is this cloud dilemma, you can say. So how it works is your organization needs to furnish the business model to NIST, and NIST will figure it out whether your particular business model is a cloud business or not. Okay, so they have certain characteristics that actually needs to be set up. There are certain definition. You call it NIST definition, and this NIST definition ensures by creating factors to compare whether your business is a cloud business or not. So first thing, they have kind of grouped these particular measures into three categories. One, they have categorized essential services. Okay, or you can say essential characteristics, not services. Second, they have service models. And third, they have deployment models. These are the three categories which your business should satisfy, and then will be announced, or then will be agreed upon as a cloud service. So when you talk about essential services, according to the definition of NIST, the standardization rules of NIST, the essential characteristics describe the core requirements of any cloud, and there are they are differentiators that determine whether the service can be classified as being a cloud offering or cloud service or not. So in the essential characteristics, you need to satisfy following, you can say, terms. So the first term or the first factor needs to be broad network access. Okay, so services that are available over the network and access via standard protocols in communication technologies of any type of client device, be it mobile phone, be it tablet, be it desktop, or so on. If that particular service is accessible on cross-platform domains, then you can say that you have achieved this broad network access. Then the second characteristics is rapid elasticity. So rapid elasticity means that capacity can be automatically provisioned and decommissioned to scale the service on demand. Which means that, you see, whenever we use kind of an AWS machine or EC2 instance, then in that, in the beginning, we can get assigned with 8 GB of RAM and maybe 512 GB of hard drive. Now our space is full. We want to double this particular thing up. So I want now 16 GB as my RAM and 1024 as my hard drive. So it is possible in AWS. So that means that you have rapid elasticity, kind of a thin provisioning manner. Whenever the requirement is there, the size will increase accordingly, and accordingly you will be charged for that. So you need the elasticity in the resources that is being provisioned to you. So if that is taken care of, you also can check your second factor as well. Then after that, the third particular parameter there is measured service. And measure service means that cloud systems that can actually measure the resource utilization, okay? Be it compute, be it storage, like I just gave you an example of hard drive and RAM, or be it network uses. All these three factors actually needs to be calculated, that how much is actually being consumed by the customer. If you can like calculate them or measure them, and then according to that, if you can charge to your customer, then that's what gonna make your service as calculated, and you can charge it according to what you're offering to the user. So utilization is kind of monitored or controlled and reported by allowing the transparency of the service provider and the customer in a basic way possible. So you need to also make sure that you have that. And once you have that, then you can check your third factor as well. And then after that, there comes the fourth factor, which is on-demand self-service. So this is pretty easy. The name itself suggests that the cloud consumer can provision compute, storage, and network, all these three factors according to its need or according to his or her need. Okay, without human interaction, it needs to be done via automation. So you need to have a portal like you have an AWS management portal, via which you can increase or decrease the resources that you want to be allocated for your EC2 instances, maybe, right? So you need full power on how much of resource do you want to use actually, based on the limitation as well. You cannot like go and say I want 100 GB of RAM and all. That won't sound that good. So based on some criteria, you need to be able to do that particular thing. So yeah, on demand self service also needs to be there. And then the fifth parameter which you have is, which is the last parameter there, is resource pooling. So the infrastructure is kind of a common pool of resources that can serve multiple customers at the same time. And the customer does not actually interact with the underlying hardware. Like for example, let's say I have an ESXi server machine. Okay, this is my server. I run an operating system called ESXi inside of it. And then I have 10 virtual machines inside of that. So the physical instance, maybe my server particular thing has 512 GB of RAM, and then I have 20 TB of hard drive. And with every virtual machine, I allocate maybe 4 GB of RAM and let's say 1 TB of hard drive. So this 4 GB and 1 TB is actually assigned to 10 different people individually. So person A is getting 4 GB and 1 TB, person B is getting 4 GB and 1 TB. But whenever, if you look at person A's perspective, then you do not actually know that the same resource, same physical resource is actually shared with 10 other guys as well. You only get to know about your allocation, and you are not aware about what's the underlay fabric that is actually being used for hosting my requirements there. So this is something that we call as resource pooling. Like we use an Uber pool to share cab or something like that. Just like that, you are sharing server space. That's why we call it as resource pooling. Okay, so resource pooling also needs to be there. And once you ensure that, then you are ensuring everything that the essential characteristics are checked and your service actually adheres the requirement of essential characteristics. Make sense? Any questions? All right. Then the next thing comes up that actually needs to be ensured for service models. So there are different, uh, I would say models, cloud models that are available. You might have heard about names as infrastructure when you talk about them. You heard about infrastructure as a service, platform as a service, and software as a service, right? IaaS, PaaS, and SaaS. So when you consider factors that how these software as a service, how these platform as a service and infrastructure as a service works, then there are certain criteria that actually needs to be managed. So if you look at traditional IT, that everything that you have is on premises. Okay, you're not renting out any resources. Then the factors would kind of be something like you'll have applications, then you'll have your data, then you'll have your runtime, then you'll have your probably middleware that is actually interacting with hardware and software. And then in the hardware section, you have operating system installed. Then you have your virtual machines installed. You have your servers there, right? Then you have your storage and you have your networking. All these criteria ensure, or these criteria are required in order to build up a strong data center there. So the IaaS, PaaS, and SaaS is actually defined in a way that how much of this is actually being rented out. If you are renting out probably maybe let's say application, data, runtime, and maybe middleware. If you are renting out only these, then you are kind of renting out infrastructure. Sorry, you are renting out not these, you are renting out these part. Okay, so you are getting infrastructure as a service. You are physically purchasing that particular infrastructure, or you are physically renting out the infrastructure, and on that infrastructure, you are installing all of your software, be it applications, data, middleware, and runtime, and all. Make sense? So that's how you can say that infrastructure is being rented out only, and the software part is managed by us. Then, if you go according to something like just application and data is yours, that's the only part that is yours. Everything, runtime, middleware, operating system, and all, everything is yours. Then you are basically renting out platform, and we call it as platform as a service. When you only manage apps and data, that's all. Okay, and if you are basically renting out everything, even software and hardware and everything, then you would call it as software as a service, because the app that you're using as well is not yours. You're also renting that particular thing out. Salesforce is kind of one of the good example there, or SAP is one of the good example there. These companies do provide software as a service in a better way possible. So that's how SaaS and PaaS and IaaS are distinguished in together. So you need to make sure that which service model do you comply with. Once you do that, then you also can check this particular box that you are working on one of the things there. But if everything is being managed by the client itself, then your service cannot be considered as a cloud service. Okay, so that's something called service models that actually needs to be considered. And then you have the application deployment model, one of the important things there. This. So if you go into application deployment model, then in that scenario, deployment model. So you have certain options inside this application deployment model. One, you can deploy it on public cloud. Second, you can deploy it in private cloud. Third, you can deploy it in hybrid cloud. These are three of the most popular options that are available there. So cloud can be deployed in number of ways, as I said, and the deployment model chosen depends on whether you want to own your own infrastructure or rent your infrastructure or have like a mixture of both. So there are multitude of reasons you might choose by considering one option over the other as well. But factors such as protecting your sensitive data and economics and speeds and all these things needs to be weighted in making choice between deployment models. So when you think about the private cloud, The private cloud is provisioned for a single organization and that may have multiple service consumers within its business units or group. For example, there is, I would say, Teachable is one of our platform, right, where you are accessing all of your recordings or so. So Teachable for PyNet Labs is combination of a private cloud there. No one else apart from the persons who are allowed to access that platform by PyNet Lab can access it. Okay, it's not a public platform that can be accessed by anyone to access our requirements. You need to enroll for that access, and then you will be provisioned the access to access the recordings lifetime there. So that can kind of be an option of public cloud, sorry, private cloud. Then after that, if you talk about public cloud means any, I would say, thing that is basically provisioned to be accessed by anyone over there. So, for example, you do access Z5, right? You do access Netflix. You do access Amazon Web Services, or Amazon, you can say Prime, in order to shop for something also. That can actually be assumed as a public cloud. So public cloud is provision for open utilization by any public at large, and anyone with a credit card can get access to a public cloud offering, and that particular public cloud exists solely of the premises of that particular cloud thing, but resources and every other thing is basically publicly shared. So you can say that AWS and Azure and every other thing as well, it's kind of public cloud where everyone can access it. But yeah, and when you talk about hybrid cloud is just as every hybrid is defined. It's basically a combination of public cloud and private cloud, for example. So a hybrid cloud is combination of both of them. It has resources that are situated on premises or off premises, and you can do orchestration between both of those particular things. So yeah, it can be a mix of both things, which means that Amazon for itself can use hybrid cloud. So it uses cloud resources that are available only for premises as well and for its customers as well. That can be one of the examples there. And there is also a fourth one, however, which is called as hybrid. Sorry, not hybrid. We already discussed about, which is called as community cloud. This community cloud is kind of unique in that it is provisioned for the sole utilization of specific community of consumers or customers, such as, for example, um, a school district, okay, or like you can say government agencies, which actually allows you to download and upload and fill in some applications for some of its service that government is providing, right? For example, if you want to apply for your passport, then the portal that is hosted there is a cloud portal, but only government is required like hosting it for the sole purpose of its residents to be like consumed with. So Indians are free to use that passport service that is hosted by the government. So that particular service will be coming in under the community cloud section. Cool. That's these are, I would say, different applications, or these are, I would say, different ways of deploying things. So when you, I would say, have a local resource available there, and that particular local resource is being actually used in order to host the application or so, you can do that there. And you can have multiple servers inside your premises and then deploy the thing and all. It's all possible in that scenario. Make sense? Any questions over here? All right, seems good. Cool. Then we will be talking about a small section which is there for application, I would say, security. Okay. So when you basically think about application security, in this section there are two factors that actually needs to be considered in order to secure when deploying application. How do you actually secure it? So first step is basically towards identifying potential risks. So Again, when you think about that, there are standards that has been defined by NIST, National Institute of Standardization, right? And this particular NIST has created a framework called cybersecurity framework. And in this cybersecurity framework, there are certain factors that actually needs to, or there are certain steps that actually needs to be followed in order to detect whether your application is secure or not, or whether there are potential risks in your application or not. So the steps are in a way that firstly you need to identify, second you need to protect, third you need to detect, fourth you need to respond, and fifth you need to recover. These are 5-step framework that they have kind of created. Now when you talk about identify, an organization who actually needs to follow this cybersecurity framework needs to understand what kind of risks can affect the daily modes of operation to the application. And areas can be data theft, or it can be network breach, or it can be employee information breach, right? These are some of the threats can actually be there. Then once you identify what kind of threat it is, then you can move towards protecting that. So the organization needs to understand what it can do in order to prevent those particular attacks. And protection can include deploying proper networking elements, okay, such as implementing firewalls, or implementing load balancer, or implementing things like URL filtering, things like SSL offloading, or such things can actually be implemented in order to protect that particular application for the better software development, right? And then once you take some measures, then you can again detect that. So it is important to install tools that can actually detect if there is any data breaches that is happening, or if there is any attack that is happening in the time sensitive manner. Okay. And because if you're not able to detect that once you deploy your hardware, then the hardware is like not properly working, I would believe. And once you detect that, then you need to respond to it. So then the company needs to have a plan in place to deal with that particular attack. It needs to know that what procedures needs to be followed, and what can be done to minimize the impact of an attack, like in terms of every kind of attack that can be there. And once it knows about how to recover, like how to respond to that, then the recovery plan should be there. Like the company needs to be able to quickly resolve the like attack, or the problem that has been caused by the attack, and bring its services back into action. Otherwise that's going to impact the business then. So these are 5 steps framework that basically is complied in the cybersecurity framework that most of the companies do follow there. And application security, as explained, uses cybersecurity framework as a, you can say, a key role to understand some of the key concepts there. So to ensure that application security is there, you need to. There is also some attacks that are performed that actually saves 4 of your assets there. So when you look at the company, then the company might have different property to it, and one of the property that a company might possess is an asset. So asset can be anything. It can be a machine, it can be a human that actually contains or that actually consumes valuable information produced by the company itself. Okay, then you have threat. So anything that you're trying to protect against is known as a threat. Your data center is a threat to you. If that particular, if anything has a weakness in it, that particular weakness is a threat to the asset that you have. So a threat is any code or any person that can exploit a vulnerability when it has access to an asset. Okay, and it can control or damage that particular asset. That can be called as threat. Very very common definition. The third thing that you can have is vulnerability. And a vulnerability is nothing but a weakness that is present into your systems. And it can be exploited by threats to gain unauthorized access, right? So it's like assets are there, and assets have some privileges to like have access of the possessions of the company. So asset can create threats can basically be used in order to like exploit a vulnerability, and when you exploit vulnerability, that actually create risk for the business. So this is all kind of interconnected together. Risk is nothing but intersection of assets, threats, and vulnerabilities. So certain risk can potentially compensate for the loss or damage of destruction of the asset or the possessions of the company then. And you deploy cybersecurity framework in order to come up with these particular things so that you minimize the entire risk of an attack from being you can say conducted or so. So that's kind of a thing that you have there. And you can also Google something called OWASP top 10. So in your exam, OWASP top 10, what is this exam? Sorry, what is this particular thing is OWASP is an organization which is actually running a project called Open Web Application Security Project. Open Web Application Security Project. This OWASP or Open Web Application Security Project is a community that produces and articulates various reports and tools and methodologies and technologies for web application security. So in the this is not concerned with the DevNet or automation stuff, but in the exam, you are going to be asked with I would say a list of, so there are top 10 threats and attacks that actually this organization articulates or publishes, and you need to know about the top 10 threats that are available there, like the list of them, and you will be prompted with a question that you will have to choose that which attack comes under the top 10 list of OWASP. That's how the exam would be. So if I just give you the list of them, one is called as injection. Injection is one of the attack. Then you have broken authentication. Then you have sensitive data exposure. Then you have fourth as XML external links. Then you have broken access control. After that, you have security misconfiguration. Then you have cross-site scripting. Then you have insecure deserialization. And after that, you have using vulnerabilities. And 10th is insufficient logging. Right, these are, I would say, kind of the vulnerabilities that can be out there. So injections can be like things like SQL injection is one of the attack there. In SQL injection, it's basically a code that you actually inject, like code injection technique that is used to modify or retrieve the data from SQL databases. So by inserting specialized SQL statements into the database that is present in the backend of the application, you can actually manipulate the thing. So injection is one of that particular thing. Then you have broken authentication where the username and password are actually not changed and they are kept as default ones. So your authentication kind of it gets considered as a broken authentication. Then you have sensitive data exposures where data can be exposed on internet and that particular data can be used in order to create vulnerability or so. You have XML external links where the XML codes are actually being exposed into the external links and they're kind of hyperlinked and those particular links are being shared, right? That particular thing can be like there. And that's how the other attacks can also be performed. Broken access control, security misconfiguration is there. Your cross-site scripting there, insecure deserialization, using vulnerabilities that are available publicly, insufficient logging also. All these particular things are into the top 10 OWASP threats. So the only thing that you need to know about them is this particular list itself. And you will be prompted with exam questions that actually needs you to identify whether the option or whether one of the option is from the top 10 threats or not. So that's what application security basically is. And yeah, nothing apart from that would kind of be asked there. And then firewalls and load balancer configs and all those are all kind of specific configurations that you can do, but in specific domains there. So this is something that actually concludes our entire training there.